been on the team since 2007 when I was an undergraduate at UMBC. And then as I moved through, I learned more and more skills. I became really interested. I talked with some people at UMBC. I ended up staying on for my master's degree, and now I'm pursuing my PhD. So I've been on the team quite a while. I think I've been to 15 races now. I am the co-captain of the UMBC Baja team, where we build this vehicle behind me and race it against over 200 teams from around the world. Planning, as you said, starts one day after the last race ends. There are 3 races throughout the season. The last one's typically in June. So we bring the team together like one day or 1 week after the last race, and we basically start talking about how we're going to design the vehicle for the up-and-coming season. We usually spend about 3 to 4 months of 40 hours, 50-hour weeks working on the design and developing it inside of a CAD software to basically get to the point where we are now. And then, as you said, some things are unexpected. So you'll start manufacturing things, something will be slightly off, or your vendor that you sourced for a component won't be able to produce it quite the way you wanted. And then you have to be able to think on the fly in order to solve problems. Or you may have a perfect design in your computer model and you've produced the part, and then through testing, after 80 hours later, the component breaks. And then we go through and instrument it in order to basically find out why it broke, and then make it stronger and fix the problems that the component may have had. There's a rule book put out by the Society of Automotive Engineers. Typically it's around 100 to 150 pages. Regulates a lot of the safety aspects of the vehicle, but also regulates things such as the motor we can use, what we can do to the motor, things of that nature, so that everything's on an even playing field. It takes a lot of time to interpret the rules and basically come up with a winning vehicle, because there still is a lot of creative freedom for the engineer to be able to go through and make a particular component a particular way. And when you end up going to the race course, you end up with 100 to 115 vehicles from different universities around the world that all have different designs, and none of them really look the same. So there is a lot of creative freedom for the engineer in the competition. What we're doing is starting up a small marketing firm, or basically an engineering firm for producing these vehicles. So you get a lot of items, like for example, we need to raise all of our own budget. All of the money from the team comes from teammates getting together with a marketing or business plan and pitching it to different aspects and organizations. And you see on those side panels a lot of our sponsors listed. So those people have basically agreed to help us with our mission of creating this vehicle, but at the same time we need to basically have marketing, computer science, networking, you have political science in terms of networking with people in order to get relationships. You have a lot of aesthetics associated with the competition. The car needs to look good, so you're bringing in art majors. We need to make sure that we stay on budget. We need to make sure that we're paying attention to economic times, so you can bring in economic basically majors into the program. So there's a lot of different aspects that you can tackle in order to bring the project from a pile of tubes in order to a complete team, basically. And you have managing aspects. You need to be able to manage your time correctly. There are a lot of teams who show up at the race and they're still basically building their car in order to get it to run, whereas we're trying to finish the car approximately 4 months before the competition. That way we have time to actually test it. So then you're getting into vehicle testing, so you need to be able to instrument vehicles. You need to be able to have the physics of the situation down. So you need to understand physics and how G-forces and other forces are applied to the vehicle. So there's a lot of different aspects of building a vehicle that necessarily don't require pure technical skill in terms of how much force does this component need to be able to handle.
So it really is kind of a community effort, really.
Yeah, that's correct. There's approximately, at any given time, 30 to 50 students. Because of the way the college architecture works, not everybody's always around. Some people have to go home during the wintertime semester, so they're not here. Or some people graduate in December. So we need to basically always figure out how to bring people into the program and how to get them up to speed as quickly as possible. So we consider that learn by doing. And what I mean by that is we've designed a component on the computer, which is where a lot of engineering classes stop. You get a design project, you design a component on the computer, and that's sufficient. But what this competition really does is it allows the engineers to try to make a design through its full entire process. And in doing that, especially when it's a very complicated thing like making a vehicle, you make mistakes. And that's actually a good thing. This gives the engineer, the designer, a safe environment to make a mistake in and basically be able to learn how to fix it. What do I enjoy the most? I think the skills that you don't learn inside of an engineering classroom. I'm an engineer by trade. I learned engineering school. I go over mechanical engineering concepts. I work with equations. But inside of those classrooms, you're really not given as many opportunities to really communicate your ideas to people and be able to really manage a team in its whole aspect. So I would say the networking with people and the basically directing the team and guiding them through the process of design and development.